Hi, and welcome to another installment of Math Basics, Mr. Besh. Today we're going to talk about plane geometry, and we're going to explore lines and line segments. The all-powerful and mighty infinite line. First, all lines are straight. Secondly, if you look at my picture here, the arrows indicate that the fact that the line goes in opposite directions forever, and that term infinity comes into play here. Things that I want you to know about a line. Number one, they're unmeasurable. We cannot measure a line. Secondly, there is no starting point and ending point, and that's the reason why it cannot be measured. But the things that we can do with this line, we can take any line and we can cut it into two places. When we cut a line into two places, now we have a designated starting point, and now we have an ending point. We can now take that piece of a line, which is defined as a line segment, and now we can measure it. We can do this two ways. These are two symbols that come into play in this unit. The first, obviously, is the equal symbol. You should all be familiar with this. The second symbol you may not recognize. This is something we can put into our tool belt. This is called the congruency symbol. Now, both of these symbols want two different things from us. Let me explain. Here's an example of a line segment. My line segment here goes from E to H and then has two stops in between, F and G. Notice if I travel from EF, you notice the little line above EF down there? That's a symbol for our line segment. If we wanted to represent the symbol for a line, we'd put an arrow at either end. But what this is saying is that line segment EF has a distance of 2. So when you travel from E to F, you're traveling a distance of 2. You take the value that's in between the two letters, and that is your value that you have. Well, sometimes you have letters in between. For instance, now, if we travel from E to G, there's an F in between E to G. So now what we have to do is take and add together our combined distances from E to F, then from F to G, so that the distance from E to G comes out to be equal to 4. Now, both of these examples here, we're using the equal sign. Now, the congruency symbol. When you see congruency, what they want is something that is exactly the same. When you see congruency, you want to think sameness. And what they're saying is there another line segment that has the same numerical value as EF? Well, we know line segment EF had a value of 2. So then we look at our line segment down here from E to H, and we wanted to try to find another line segment that also had a numerical value of 2. And that would be line segment FG. This is very important. From time to time in homework and quizzes, a lot of times students get in a routine where they just keep putting numbers down for equal signs, and they don't necessarily pay attention to the symbol. The symbols here are very important. Notice this congruency symbol is something that's going to come up later on down the road in other units because it works with all types of expressions. You see, we can have congruent angle measurements. We can have congruent triangles. We can have congruent rectangles. So it's very important that we make sure that we understand what this symbol means. Again, when you see the congruency symbol, you do not want a number answer. You want an expression or something that is exactly the same. Now, our next topic is talking about the types of lines. If I pose this to my classes, a lot of times students make this mistake. They go 50-50. They always say parallel and perpendicular. Well, they get the first part right, parallel. We know by definition parallel lines are two lines that never meet. Now, I want you to take a look at the symbol for parallel lines. It's just simply two line segments going straight up and down of equal length, just like this. What I want you to know about parallel lines is the fact that if I measure two parallel lines, the distance across from one line segment to the other line segment, I will always have exactly the same distance. We can see parallel lines every day when we're driving on the streets, sometimes straightaways in between, the line that divides the road from the left side and the right side. Train tracks. Notice on straightaways and train tracks, the tracks are always the same distance apart over and over again. So parallel lines is usually one that students tend to have a pretty strong grasp about. The other type of line that exists is an intersecting line. By definition, these are lines that actually meet. Now, when two lines meet, they only meet in one point ever. They can never meet in more than one point, because now what you're talking about is these lines would have to bend, they would have to arc, and that's not the definition of lines. So when you know that two lines meet, they intersect in one point, and that's what they're referred to as intersecting lines. Notice the example that I used from social studies class, geography, our little compass symbol, north, south, east, and west. Another thing that I want you to notice that's going to come up in other sections is the fact that when two lines cross, they end up forming 4 different angles. And we'll talk about this a little bit later on. Now, there's a very type or special type of intersecting line, and that's your perpendicular lines. Here's the symbol for perpendicular. Now, what I want you to know about perpendicular lines is, yeah, they're intersecting lines. Two lines that are perpendicular cross. Literally, they make a cross. You would notice it as being a giant plus sign. But the thing about perpendicular lines that's very important is when two lines are perpendicular, they form a 90-degree angle. Let me show you a little example here, a difference about just intersecting, plain old intersecting, and perpendicular. Intersecting can be generic. Two lines can intersect basically anywhere. But when you talk about perpendicular lines, when the two lines, they make a gigantic plus sign. And notice this plus sign can be broken into like 4 little L regions, upside down, left to right, okay? When this happens, they form 90-degree angles. As a matter of fact, when you see that box inside there in geometry, that box identifies as a 90-degree angle. Now notice that there's only one box in there. When you see one box and two lines crossing, I want you to realize that you could put a box in any one of those 4 angles that are being made. All you need to do basically is show one. Putting in more than one, that would be redundant, but that does in fact exist. When two lines are perpendicular, they form 4 90-degree angles. Ladies and gentlemen, this was lines and line segments. I hope you found this both helpful and informative.